Hey, this is Ryan from Learnometrics Tutoring, and today we're going to be going over our first video on the statics example problems. We're going to be covering mostly just unit conversions, getting you back into the swing of things with engineering. Unit conversions are one of the most critical skills you can have as an engineer, and they will help you solve problems that you wouldn't otherwise know how to solve. So let's get started. All right, so here's our first problem. Now, when you're reading problems, even if they're simple, I recommend reading them out loud because it makes it harder to miss the key information. So the Burj Dubai, scheduled for completion in 2008, will be the world's tallest building with a height of 705 meters. The area of its ground footprint will be 8,000 meters squared. Converts its height and footprint area to US customary units to 3 significant digits. Okay, so the key numbers for this problem: 705, 8,000, US customary, and then 3 sig figs. So that's what I need to do with this problem. First, we're going to do part A, which is converting 705 meters to feet. Now, there's an easy way to do this, and if you have a cheat sheet where you know the unit or you can Google it, I'm going to do the long way first and then the short way. So 705 meters. And then I'm going to draw a long dividing line that I always do when I do units, because this will let me keep it nice and organized instead of doing a bunch of multiplication signs. So I know that 1 meter has 100 centimeters. I know that 2.54 centimeters goes into 1 inch. And then I know that there's 12 inches in 1 foot. So then I go through and I just cancel. And the result is going to be 2,312.99 feet. Now, if you put this would be wrong because it only wants us to have 3 sig figs. So our final answer is actually going to be 2,310 feet for part A. The fast way to do it is to Google that the conversion between meters to feet is going to be 3.281 feet per meter. So if we do that, then we'll get the exact same answer of 2,310 feet. So having a cheat sheet for your unit conversions is going to be really important, especially since with the way tests are going, you're going to be able to have a cheat sheet for most exams. So I have a link in the description of the cheat sheet that I made for units. Recommend you download it. It'll be helpful for you. All right, so that's part A. Now part B is going to be doing 8,000 meters squared. The only difference between converting 8,000 meters squared to feet squared is going to be that we need to square every single term that we're doing. So I'm going to write 8,000 meters squared here, and I know I'm going to end up in feet. So I'm going to do the longer way just to show you guys better what happens when you have to convert squared units. So I need to get 1 meter squared in the bottom. So that means I need to square both terms. Really what you're doing is you're doing parentheses squared, but I just like writing the squareds outside because then I can cancel these directly rather than having to do it through the parentheses. So that's going to be not 2.54. That's going to be 100 centimeters squared, 2.54 centimeters squared for 1 inch squared. And you don't need the squared on the 1, but I just do it for completion's sake. 12 squared, inches squared, 1 foot squared. So now, and this is why I write it outside the parentheses, I can just go through and cancel these the unit terms, and I'm left with feet squared. So here is the result: 86,111.28 feet squared. Now, we want to do this in sig figs, the easiest way to make sure you don't have problems with your sig figs is to, rather than writing it like we did up here with trailing zeros, do it in scientific notation. So this is 8.61 e to the 4 feet squared. E to the 4 is the same thing as 8.61 times 10 to the 4. So either one of those two would be your answer for part B. And with this, you don't have to worry about kind of the trailing numbers, which are all right here. Or sorry, not that one. Which are all right here, because you just need to make sure there's 3 digits in your scientific notation. All right, here's our second problem. Again, read out loud and underline what's important. The maglev, magnetic levitation train, from Shanghai to the airport at Pudong reaches a speed of 430 kilometers per hour. Man, I wish we had trains that fast in the US. Determine its speed in miles per hour and feet per second. So we're converting 430 kilometers an hour to miles per hour and feet per second, and there's no required sig fig number. So usually I just go to 2 decimal places. If there's nothing, then I just assume 2 decimal places. It's a safe bet. You'll never get marked wrong for it unless they specifically say otherwise. So for part A, we want to convert kilometers per hour to miles per hour. So we can use the above method, which is the longer one, where we convert from kilometers to meters to centimeters to inches. We're just going to use the short one because we have a cheat sheet. So 430 kilometers per hour times 0.6214 miles per kilometer. Those 2 units cancel. We're left with miles per hour, which is what we want. So we want 430 times 0.6214, and we get 267.20 miles per hour. Now for part 2, we want to convert it to feet per second. So we can use the same unit conversion from above. We can copy and paste it, or we can just rewrite it. I'm just going to rewrite it because I want to make a larger line here. Let's make it that long. All right, so we have 430 kilometers per hour. Then we have 1 kilometer, 0.6214 miles. 1 mile contains 5,280 feet. And then our final one is going to be 1 hour, because we want to end up in seconds, is 3,600 seconds in the denominator. And so that answer is going to be 391.90 feet per second. I really wish we had trains that fast in the US. But this is your answer for this problem. Now this problem is going to introduce you to the worst unit in the English system. It's called the slug. And we'll be able to explore that together. So we start, like usual, by reading to see what's important out loud. The kinetic energy of the man in active example 1.1 is defined by 1/2 mv squared. Okay, so that's important. Where m is his mass and v is his velocity. The man's mass is 68 kilograms, and he is moving at 6 meters per second. So his kinetic energy is the equation, 1224 kilogram meters squared per second squared. What is its kinetic energy in US customary unit? All right, so for this problem, we need to convert 2 things. We need to convert kilograms, which is metric, to the US customary unit, the slug. The slug is annoying to deal with. The second one is we need to convert meters squared per second squared to feet squared per second squared. We aren't going to have to do anything with time because time is universal. So let's start with the slug. So we have 68 kilograms. Now, if we look up the conversion on Google, we get that 14.58 kilograms is equal to 1 slug. And we can use that and solve the problem. But I guarantee you the slug will confuse you unless you nail it down early on. So let's spend some time exploring what the slug is. One slug is an amount of mass. Specifically, it's the amount of mass that when pushed with 1 pound force, it accelerates at 1 foot per second squared. That's the definition of the slug. It's not very useful. The other way to think about it is that one slug is equal to 32.174 pound mass. The key equations that you want to keep in mind with the slug that are going to help you with the definitions is 1 pound force equals 1 slug times 1 foot per second squared, and 1 pound force, if we do this substitution here, equals 32.174 pound mass times 1 foot per second squared. You're going to want to keep these two equations on a cheat sheet for a note. But going back to the problem up here, we have 68 kilograms is 4.664 slugs. Now, I added the extra decimal here because we aren't at our answer yet, so I just carry a few more decimals through the problem as I'm solving. The next one's going to be meters squared converting to seconds squared, or sorry, feet squared. So meters squared, feet squared. If we look at that conversion, that is 3.281 squared feet squared per meter squared. So that's going to be, so our next bit is converting meters squared to feet squared. So we're going to have, we have 6 meters squared per second squared. I'm just leaving the, our next piece is going to be converting 6 squared, meters squared per second squared, into feet squared. Now, seconds doesn't change, so we can just do the direct conversion. 1 meter squared and 3.281 squared feet squared is going to give us a value of 387.539 feet squared per second squared. All right, we're almost done with the problem. Now we just need to take these values and calculate our new kinetic energy. So our kinetic energy is 1/2 times the value from above in slugs and the value from above in feet squared per second squared. These values are going to be 4.664 slugs and 387.539 feet squared. So our kinetic energy in English units is going to be 903.74 slug feet squared per second squared. And that is your first experience with the wonderful unit of slug and the pound mass and pound force definitions in the English system. A brief note on pound force and pound mass. Oftentimes, these are labeled just as pound. They don't have the pound F or pound M. So you need to tell the difference by context. Generally, if it's being multiplied by gravity, it's pound mass. If it's not being multiplied by gravity, it's pound force. But you have to look at the units around it and see what's happening. That's it for this video. If you want to download the cheat sheet, you can check down the description. If you want a few more example problems on this topic, you can also look in the description for a link to a course where I go over a few more of these examples in detail. Thanks. I'll see you again.